So let us see this next question. Question number 33. Two SHMs are represented by the equations. Y1 is equal to 0.1 sin 100 pi t plus pi by 3 and Y2 is equal to 0.1 cos 100 pi t. The phase difference of velocity of the particle 2 with respect to the velocity of particle 1 is the answer मध्ये प्लस मायनस साइन दिलेले ते साइन महत्वाचे म्हणून खरा प्रॉब्लेम इम्पॉर्टंट आहे ओके so we are given the displacement and we have to find the phase difference between the velocity. So from displacement we can find the velocity by taking the time derivative. So the first displacement is given by for first displacement y1 is equal to 0.1 sine of 100 pi t plus pi by 3. This is equation 1. Therefore, velocity of first SHM v1 is equal to dy1 by dt. याचा डेरिव्हेटिव्ह आपल्याला घ्यायचा आहे 0.1 साईनचा डेरिव्हेटिव्ह कॉस इंटू 100 पाय टी प्लस पाय बाय 3 प्लस this function. So this is equation 2. Now velocity of second SHM can be calculated like this. For second SHM, displacement y2 is equal to 0.1 cos of 100 pi t. This is equation 3. Therefore, velocity v2 is equal to dy2 by dt is equal to 0.1 cos and derivative minus sin so is a 105 20. T का मल्टीप्लाई करून घ्यावा लागेल आपल्याला 0.1 मल्टीप्लाइड बाय 100 पाय इथे पण तसं होईल 0.1 into 100 pi into cos of 100 pi t. So when we are to compare the phases in both the equation there should be this is cos and derivative sin like this. So here the arrangement is important. V2 is equal to this is 0.1 multiplied by 100 pi as it is into. Now here there is a cos. Therefore here we have to add the cos and this function is given by minus sign will be absorbed 0.1 cos of 100 pi t plus pi by 2. So check this value. Cos of 100 pi t plus pi by 2 is equal to cos of 100 pi t into cos of pi by 2 minus sin of 100 pi t into sin of pi by 2. So cos of pi by t is 0 minus sin of pi by 2 is equal to 1. So minus sin of 100 pi t can be written as a cos of 100 pi t plus like this. So this is equal to this minus sin of 100 pi t can be written as the cos. This is equation 4. So equation 2 and 4. Equation 2 and 4 show that phase difference between V1 and V2 is delta phi is equal to phi 2 minus phi 1 is equal to 100 pi t plus pi by 2 minus 100 pi t. दोघे ठिकाणी कॉस्ट असलं आपण डायरेक्ट कंपेअर करू शकतो minus pi by 3. So this is equal to pi by 2 minus pi by 3, so that is equal to pi by 6. So delta phi is equal to pi by 6. आता साइन प्लस घ्यायचं का मायनस घ्यायचं, आणि आपल्याकडे दोघी चॉईस दिलेले आहेत, प्लस पाय बाय 6 पण दिलेलं आहे आणि मायनस पाय बाय 6 पण दिलेलं आहे. सो वेदर बी इज करेक्ट और सी इज करेक्ट, that now we have to decide. Since phi 2 is greater than phi 1 by pi by 6, therefore V2 leads ahead V1 by pi by 6 radian. So this is the answer. V2 is having phase difference more than the particle, the phase difference of particle 2 with respect to the velocity of particle 1 is given by this value. So the unit meter loss other is minus sign also. So correct answer is the B. Therefore B is correct. The B is correct. So we should know basic trigonometry for this problem. Actually, if you see these two equations, y1 and y2, equation 1 and equation 3. So this bracket is in terms of sine, this is in terms of cos. तर इथे कॉसच्या ऐवजी आपण जर साइन जर घेतला तर साइन ऑफ पाय बाय टी प्लस पाय बाय 2. सो फेज डिफरन्स बिटवीन y1 and y2 इज ऑल्सो पाय बाय 6. फेज डिफरन्स between v1 and v2 is also pi by 6. So phase difference between the two displacement, phase difference between the two velocity and phase difference between the two acceleration in linear system remains the same. But to compare whether this lead or lag. So for comparing lead or lag, we have to take the derivative. फक्त आपल्याला मॅग्निट्यूड पाहिजे असेल तर डिस्प्लेसमेंट y1 y2 मधला जो फेज डिफरन्स येईल तोच वेलॉसिटीमधला तोच ॲक्सेलरेशनमध्ये सुद्धा येणार आहे. त्याच्यामुळे एवढे कॅल्क्युलेशन करण्याची गरज नाही. लक्षात, वी टू डिसाइड प्लस और मायनस and therefore lead or lag, and therefore we have to take the derivative like this. Next, 34. A mass capital M is suspended from a light spring. An additional mass M added displaces the spring further by distance x. Now the combined mass will oscillate on the spring with the period. So the arrangement is like this. This is a spiral spring. This is its equilibrium position of mass m o. Now from this equilibrium position it is pulled down to the new position by adding mass small m. So this distance is x. So we have to find the period. So our spring pendulum period capital T is equal to 2 pi multiplied by under root of MO by K. So remember this symbol MO, where MO is equal to mass of oscillating body. And in our example, both the bodies M and M together, they are oscillating. So this part is important. So this is equation 1, this is equation 2. In displaced position E, force, restoring force, due to elasticity acting on M is equal to gravitational force acting on M. So Fe is equal to Fg. So this is equal to Kx is equal to M into G. And therefore K is equal to Mg upon X. इथे कैपिटल M कुठे देणार? This is equation 3. So 14(1), therefore period capital T is equal to 2 pi multiplied by under root of MO is equal to M plus M. हा M जो तो स्प्रिंगला एलिमिनेट करण्यासाठी यूज केलेला आहे. ही त्याची इक्विलिब्रियम पोझिशन आहे अपॉन M into G upon X. So this X will go up. So this is equal to 2 pi multiplied by under root of capital M plus some small m into X divided by mv. Like this. So this is the correct relation, and therefore B choice is correct. B is correct. and 35 both are based on the same relation. A mass capital M attached to the spring oscillates with a period of 2 seconds. If the mass is increased by 4 kg, the time period increases by 1 second. Assuming Hooke's law is obeyed, the initial mass capital M once. So again we will use the same formula for spring pendulum. Spring pendulum period capital T is equal to 2 pi multiplied by under root m by k. Since spring is remaining same, therefore k is constant. Therefore, period is directly proportional to square root of m. This is equation A. When m1 is equal to capital M, then period t1 is equal to 2 seconds. Check the value. For first mass m period is 2 seconds and m2 is equal to m plus 4, then period t2 is equal to 2 plus 1, that is equal to 3 seconds. So we have to find capital M. Therefore, equation A gives T1 upon T2 is equal to under root M1 upon M2, directly proportional to square root of M. So substitute the value. So 2 by 3 is equal to under root M1 is equal to M and this is equal to M plus 4. So squaring. You have to find capital M. So 4 by 9 is equal to M upon M plus 4. Therefore, 4 times M plus 16 is equal to 9 times M. Therefore, 16 is equal to 9 times capital M minus 4 times capital M is equal to 5 times capital M. Therefore, initial mass M is equal to 16 by 5, that is equal to 3.2 kg. So, initial mass attached to the spring capital M is equal to 3.2 kilogram. 3.2 kilogram. And therefore, the correct choice is A. Next, question number 36. It is a new type. If length of the second pendulum is increased by 2%, how many seconds it will lose per day? Actually, इथे lose शब्द त्यांनी देऊन टाकलेला नाही, आपल्याला ते विचारता whether it will lose or gain, by how much time the clock will lose or gain per day. So why the clock loses? The reason is very simple. We know the formula for pendulum. T is equal to 2 pi multiplied by under root L by K. So when length increases, period increases. So period increases means pendulum will become slow. Therefore, the clock controlled by this type of pendulum will run slowly. So when the hands of the clock run slowly, definitely it will show less time. त्याला आपण मागे घड्याळ मागे पडणं म्हणतो आपण. So the clock will lose by some finite time. So we have to find that time for 1 day. 1 day means 86,400 seconds, like this. So we are using simple method, and that method is called the error analysis method. So we know the formula for period. Period of simple pendulum capital T is equal to 2 pi multiplied by under root L by D is equal to 2 pi upon under root G into L raised to 1 half. So T is equal to this 2 pi upon root G is replaced by K into L raised to 1 half. So this is equation 1, where K is equal to 2 pi multiplied by under root G, like this. Differentiate म्हणजे derivative घ्यायचा. Differentiate one on both sides. Therefore, dt is equal to 1 half k into L raised to 1 half minus 1 into dl. So this is equal to 1 half k L raised to minus 1 half into dl, and therefore dt is equal to 1 half k upon L raised to 1 half खाली गेल्यानंतर तो प्लस होता है into dl. This is equation second. So 2 pi 1 gives dt upon t is equal to 1 half k into L raised to 1 half dl upon k into L raised to 1 half. So this is equal to 1 half k cancel, so dl upon L raised to 1 half into L raised to 1 half. So this is equal to 1 half dl upon L. So this relation we can use directly. Therefore dt upon t multiplied by 100 is equal to 1 half dl upon L multiplied by 100. Mathematically you can write down this equation. Therefore the percentage change in period is equal to 1 half percentage change in length. This is the important relation. So percentage change in length is given 2%. And that dt upon t is equal to 1 half percent मध्ये is equal to 2%. So 2 upon 100. So that is equal to 1 upon 100. That is equal to 0.01 second. Therefore, delta t is equal to 0.01 multiplied by capital T. So this is equation 3. For second pendulum, the problem is of second pendulum. For second pendulum, period capital T is equal to 2 seconds. Therefore, delta T is equal to 0.01 multiplied by 2, that is equal to 0.02 seconds. This is equation. This is equation. So as length L increases, period capital T also increases. Therefore, the pendulum oscillates slowly, and hence the clock controlled or regulated, the clock controlled by such pendulum, the clock controlled by such a pendulum will run slowly, and therefore the clock loses. So why the clock loses? This is the reason. So in time t is equal to 2 seconds, the clock loses by delta t is equal to pointer in order 2 seconds. Hence, in one day, that is 24 hours, is equal to 24 multiplied by 60 multiplied by 60 seconds, that is equal to 86,400 seconds. The clock will, in one day, the clock will lose by t second given by. So the equation is very simple. In 2 seconds, the clock loses by 0.02 seconds. Therefore, in 86,400 seconds, it will lose by t. And therefore, the time by which the clock loses small t is equal to. The equation फक्त आपल्याला solve करायचं आहे. So this is equal to 86,400 upon 2 multiplied by 0.02. So 86,400 multiplied by 0.01. So that is equal to 864 seconds. Therefore, in one day, in one complete day, clock will lose, the clock will lose by, the clock will lose by 864 seconds. This is the correct answer. So when the length increases, the pendulum becomes slow, therefore the clock regulated by such a pendulum will also run slowly, therefore the clock will lose. If length कमी झाली तर मग उलट जाईल. Length decreases, period decreases, the clock will run faster, and in that case the clock will gain. Lose or gain चा meaning आपल्याला माहिती. Lose म्हणजे मागे पडणे and gain म्हणजे पुढे जाणे. So in one day the clock will lose by this much second. पण त्याचे मिनिट आणि सेकंड आपण करू शकतो. म्हणजे त्याला 60 ने आपल्याला डिवाइड करावं लागेल. 14 मिनिट आणि काहीतरी सेकंड येतील. सो 864 seconds is equal to 864 upon 60. So that is equal to 86.4 upon 6. So that is equal to 14 minutes and 4 seconds. the clock will lose by 14 minutes and 4 seconds. Like this. So remember the solution. So here we have used the error method. dt is the error in the measurement of time t, and this error occurs because there is a error in the measurement of length. So length increases by 1%, change in length is 1%, so period also increases. There is a plus sign. इथे जर मायनस साइन आलं असतं तर उलटं झालं असतं मग. In that case length will increase and period will decrease if there is a minus sign, but there is a plus sign, so they are directly proportional. So length increases by 1%, 2%, period increases by 1%. So simple pendulum is a second pendulum. For second pendulum, this period is equal to 2 seconds. So in 2 seconds, the clock will lose by 0.02 seconds. Delta t is equal to 0.02 seconds. This is the change in the period of the second pendulum. So in time t is equal to 2 seconds, the clock loses by 0.02 seconds. Therefore, in one complete day, that is 86,400 seconds, the clock will lose by this much time, 864 seconds, like this. Next, a pendulum clock is placed on the moon where the object weighs only 1/6 as much as on the earth. How many seconds the clock tick out? In an actual time of 1 minute, the clock keeps good time on earth. So how many times we can hold the tick of the clock in 1 minute on the surface of moon, that we have to find them. And for that purpose we have to find the period. So for simple pendulum, period capital T is equal to 2 pi multiplied by under root L by T. Since L is remaining same on moon, therefore period capital T is inversely proportional to square root of V. Therefore T on moon divided by T on earth is equal to under root of G earth upon G moon. G moon, like this. Since the body weighs 1/6 on surface of moon, then that on earth, therefore weight on the moon is equal to 1/6 weight on the earth. Therefore m into G on moon is equal to m 1/6 m into G on earth. Therefore G moon is equal to 1/6 of G of earth. So this is equation 1, this is equation 2. Put 2 in 1. Therefore T on the surface of moon, T on the surface of earth is equal to under root. So we have to put this value 1/6 G. So that is equal to root of 6. Root of 6. So T moon is equal to root of 6 times T earth. This is equation 3. So on earth the clock will tick 60 times in 1 minute. On the surface of moon it will tick root 6 times 60. The answer root 6 ने आपल्याला मल्टिप्लाय करावं लागेल. root 6 multiplied by divided by 60. On earth period वाढला म्हणजे ते कमी वेळात टिक टिक करेल. On earth the clock ticks. आपल्याला फ्रिक्वेन्सी भेटेल. फ्रिक्वेन्सी n on moon is equal to 1 upon root 6 times frequency on earth. Since on earth the clock ticks 60 times per minute, the frequency is per minute, therefore frequency on earth is equal to 60 ticks per minute. Therefore T moon is equal to n earth by root 6, that is equal to 60 upon root 6, 60 upon root 6 is equal to 60 multiplied by root 6, root 6 multiplied by root 6, that is equal to 60 upon 6 multiplied by root of 6. The root of 6 ची व्हॅल्यू आपण स्क्वेअर रूटच्या टेबलमध्ये डायरेक्ट बघू शकतो. सो रूट ऑफ 6 इज इक्वल टू 1.667. Sorry, root of 6 is equal to 2.449, nearly 2.5 घेतलेला असतो. 2.449, so that is equal to 10 multiplied by 2.449. So 24.49 ticks per minute. So that is nearly 24.5 ticks per minute. Therefore, the clock will tick. The clock will tick 24.5 times per minute on moon. The clock will tick 24.5 times per minute. Like this. So the correct answer is B. So what to find frequency, not a period. The period of the reciprocal घेतलं frequency मिळेल. So frequency of ticking on the moon is 1 upon root 6 times the frequency of ticking on the earth of the clock. Like this. Question number 38. The problem is very simple. Actually the problem वाचायला जास्त वेळ लागतो. Solution त्याच्यापेक्षा कमी वेळ लागेल. A heavy sphere of mass m is suspended by a string of length L. The sphere is made to revolve above a vertical line passing through a point of suspension in a horizontal circle such that the string always remains inclined to the vertical at angle theta. What is the period of revolution. The situation याप्रमाणे. This is a rigid photo from which a heavy sphere is suspended. Now it is taken sideways like this, and it is revolved. It is taken sideways by angle theta, and then it is revolved in a horizontal circle. So this length is L. So this is a conical pendulum. So period of conical pendulum, we have derived this formula. Period for conical pendulum T is equal to 2 pi multiplied by under root of L cos theta by G. We have derived this relation, so no need to derive this relation. This is a bob of mass M like this. So the correct choice is the B. Therefore, B is correct. Next, question number 39. A body of mass 0.01 kg execute SHM about x is equal to 0 under the influence of the force shown in the figure. The period of SHM is. आपल्याला ग्राफ जो दिला त्या ग्राफचा यूज काय तो आपल्याला कळला पाहिजे. सो the mass execute SHM means it is a spring pendulum. For spring pendulum, period capital T is equal to 2 pi multiplied by under root m by k. This is equation 1, where m is given 0.01 kg and k is a force constant. It is given by f by x. So a graph is given f x. So the graph has nature straight line and it is given like this. So this value is f is equal to 80 Newton, corresponding x is equal to minus 0.2 meter. This value is f is equal to minus 80 Newton, and this is x is equal to plus 0.2 meter. So since force F is equal to minus kx, therefore 80 Newton is equal to minus k times minus 0.2 upon हे दोन पॉइंट यूज करें, and therefore k is equal to 80 upon 0.2, that is equal to 800 upon 2, that is equal to 400 Newton per meter. This is equation 2. So we know both the values. So put 2 in 1. Therefore period is equal to 2 pi multiplied by under root m. M is equal to 0.011400. So that is equal to 2 pi multiplied by multiplied by under root 0.01 upon 400. So that is equal to 2 pi multiplied by 0.01 the root 0.18 and 400 the root 28. So 3.142 multiplied by 0.1 upon 10. So 3.14 multiplied by 0.01, that is equal to 0.0314 seconds. So the period of oscillation will be equal to this much. So D choice is correct. D is correct. D is correct. Last question, question number 40. It is a short question. If mass of an oscillator is numerically equal to the force constant, then its frequency is given. M is equal to K, frequency N is equal to question mark. For spring pendulum, periodic capital T is equal to 2 pi multiplied by under root M by T. Frequency N is equal to 1 upon 2 pi multiplied by under root K by M. But M is equal to K, therefore N is equal to 1 upon 2 pi under root 1. So frequency N is equal to 1 upon 2 pi hertz. So this is the frequency of oscillation. Frequency of oscillator. Frequency of oscillator. Therefore, D choice is correct. So we have completed this paper for the chapter oscillation. Now next time we will start new chapter, maybe gravitation. Actually superposition of waves, the chapter is similar to this oscillation because both uses the property of SHM, but we have not completed it in our regular course, and that's why we may take the gravitation because that part is completed in last year in 11th standard. So we will start for gravitation. Okay, we will stop here.